Hey everyone, today we're going to be learning about complex fractions. So this is in our rational functions unit. So let's start off by talking about what is a complex fraction, because it definitely sounds a little bit scary. A complex fraction is a fraction within a fraction. Okay, so our steps for simplifying a complex fraction. Well, you're going to add or subtract, depending on what you're dealing with, to get one fraction over another fraction. So you just want it to be one fraction over top of another fraction. And then you're going to rewrite the fractions side by side. So it'll look something like this. You'll have some A over some B divided by some C over some D. And then, of course, you're going to divide. But when we divide fractions, we're going to keep, change, flip. So then it becomes the first fraction stays the same, multiplication, and then we flip the second. So our first complex fraction actually is not too terribly complex because we already have one fraction divided by one fraction. So I'm just going to rewrite them side by side. Okay, and then I'm going to keep, change, flip. So keep the first, change the multiplication, and flip the second. Now I'm going to simplify because we're multiplying, right? This takes us back to what we were doing previously with multiplication. We can cross out, an x from the top and the bottom. We can cross out a 4 from the top and from the bottom. And then we're left with 1x or x in the numerator. And then in the denominator, we have 2. So there's my fully simplified fraction. All right, my second complex fraction is a little bit more complex because notice your numerator, right, is not one fraction. So we're definitely going to want to do some side work there. So we have 2 minus 1 over x. So the first thing we need to do when we're adding or subtracting fractions is get our LCD. And the LCD between 1 and x is x. So our first fraction has to be multiplied by x over x to get me 2x over x, and then minus 1 over x. Second fraction doesn't have to change. So that's going to get me 2x minus 1 over x. So this is now my numerator. Okay, so I'm going to rewrite the fractions side by side. So 2x minus 1 divided by x divided by x. Okay, and then we are going to keep the first, change multiplication, and flip the second. And then we'll notice that when we multiply this time, we can't cross anything out, and that's okay. But there is my final right there. All right, so here's our next problem. Got 6 over x minus 1 minus 3 all over 3 over x. So again, our numerator is not one fraction, so we need to get it to be one fraction. We have to get a common denominator. Our common denominator is going to be x minus 1. So the first fraction does not change, but my second fraction gets multiplied by x minus 1 over x minus 1. So my numerator becomes 3x minus 3, and my denominator is still x minus 1. So now we are subtracting, so make sure you distribute that negative. So it's 6 minus negative 3, that's 9, and nothing minus 3x, that's still going to be minus 3x, over x minus 1. So now we have one fraction in the numerator, one in the denominator, so let's rewrite them side by side. Okay, and then we're going to keep, change, flip. Okay, and there's actually one more thing we can do here. Because 9 minus 3x, you can take a 3 out of both of those. Okay, we're actually able to cross out this 3 and this 3. So in my numerator, I have just an x times 3 minus x over x minus 1. I could leave it like that. If I wanted to, I could also multiply the x through to get 3x minus x squared over x minus 1. So either of those two circled answers is correct. All right, so that's it for what's on the note sheet. We're going to do some more practice in class, but I'm going to do some with you right now. So here's the next one. So notice the numerator is already one fraction, but the denominator is not. So we want to get a common denominator. That common denominator is going to be x. Okay, so my first fraction, we multiply by x over x to get 2x over x plus 1 over x. That gets me 2x plus 1 over x. So we keep the first fraction, we change the multiplication, and we flip the second fraction. And that gets us an x up top, and then down below we have x minus 2 times 2x plus 1, and you can leave it just like that. Okay, the next one gets looks a little bit more complicated, but it's still not very bad. So we have x over x squared minus 4 plus 1 over x plus 2. So we're going to factor our denominator here, and we'll notice that our LCD is going to be x squared minus 4, or x plus 2, x minus 2. Okay, so that just means we have to multiply our second fraction by x minus 2 over x minus 2. So first fraction stays the same. Second fraction becomes x minus 2 over x squared minus 4. And then we add to get 2x minus 2 over x squared minus 4. So now we can keep this first fraction, change multiplication, and flip the second fraction. And really nothing's going to happen there. That's going to stay as is pretty much. You could distribute the x through. You don't have to. But nothing will cancel for you. All right, this is the one that I really wanted to get to. I'm not super concerned about that one. So I want to do one more here in this video. This one, notice you have 2 fractions in the numerator, 2 fractions in the denominator. Okay, so let's start with the numerator first. So y minus 2 over 5 plus 1 over x minus 7. So my LCD for that is going to be 5 times x minus 7. So my first fraction gets multiplied by x minus 7 over x minus 7. And that's going, I actually have to multiply this out. It's a binomial times a binomial. So x times y is xy. X times negative 2 is negative 2x. Negative 7 times y is negative 7y. Negative 7 times negative 2 is positive 14 over my LCD. Then my second fraction gets multiplied just by 5 over 5. So that one's a lot nicer. Okay, and then we can only combine the 14 and the 5. Minus 7. Okay, so this, I'm going to put like a little purple box around it to remind myself that that's my numerator. Okay, so now let's talk about the denominator. Okay, so between these two, the LCD is actually going to be x times x plus 1. So my first fraction gets multiplied by x plus 1 over x plus 1, and that's going to get me 3x plus 3 over my LCD. All right. My second fraction just gets multiplied by x over x. So it's going to be minus 5x squared over my LCD. So I end up getting minus 5x squared plus 3x plus 3 over the LCD of x times x plus 1. So here's my numerator, here's my denominator. So we're going to keep this numerator as is. We're going to change to multiplication and we're going to flip our second. So it's x times x plus 1 all over negative 5x, oops, um, negative 5x squared plus 3x plus 3. All right. And nothing is going to cancel here for me, and I would not want to do a 4 term times this guy, so I would leave it as is. So you have an x plus 1, and then you have an xy minus 2x minus 7y plus 19 all over 5 times x minus 7 times negative 5x squared plus 3x plus 3. And that is supposed to be a 19 there. It just got a little bunched. So there's your final. And that is how you deal with complex fractions.